And I have everything in storage crates anyways.
Wait, but when you die, you don't have a new body after that. The old one stays, so you die again.
Yeah, because then you can go and cook it and eat it.
Yeah.
So wait, you stay the same. You can like drag your body.
So there's like penalties to die.
Well, there is a penalty to dying because you lose all your resources that you had on your guy, unless you go back and reclaim them. But you have to find where you were.
We'll just dump a bunch of stuff in store.
And you also have to hope that somebody else hasn't already come and looted your body and that a dinosaur hasn't eaten you.
Yeah, piranhas ate one of my tribesmen.
Yeah, it's awesome.
It was awesome. It was great. I met my tribe because I accidentally killed the guy.
Well, I get sad because the only thing my guy's like level 8. The only thing I could like consistently kill are like the dodo birds, and it's so sad when you're killing them because they don't even fight back, and you're just hitting them with the face with a club, and they get all bloody and stuff. It's terrible. Well, club or axe, whatever whatever you're using. Sometimes I just use my fists.
You just get an army of dodo birds. Just like bring them all in your
They're
house.
useless.
It doesn't matter. Just like have an army.
I haven't tamed anything yet. I didn't. I guess I didn't know how.
Oh, if you tame male and female dodo birds, they'll fuck. And then you can,
this is the conversation I've been having with people lately.
they'll,
What's up with his Concordia students just left and right dropping F-bombs in class? Well, yeah, so he's like a bad influence for everybody else?
Sure.
have it from the army. I tried.
When you're in like mixed company, we have to learn some self-control.
Okay, they mate, and then you can eat the young.
It's like making popcorn. All right.
That's why I have 10 dodo birds. I had 10 at my house.
All right. So the question is why did we move our queues into their own data structure? What are some reasonable answers to that question?
Two-way communication between the process scheduler and the CPU scheduler.
Okay, so on one hand, we need both the CPU scheduler and the process scheduler to both have access to those queues. One of them fills the queues, the other one feeds off the queues, right? Okay, so it kind of fulfills our singleton design pattern for that. Okay, what else? So that's from the perspective of our queue factory. The queue factory is our singleton design pattern. Then we had something else called a PSQ. That's a reasonable answer he gave. But if you happen to talk about it from the perspective of PSQ, what's the advantage that guy gave us? When we add something to a queue, we might add it with priority, right? Okay, so we kind of wanted to put that logic in one place rather than having all these little helper functions sitting inside the process scheduler and how to work with his various linked lists, correct? So now we have the ability to optionally add a PCB to a queue with priority, right? We add a second parameter to that, was that PSQ? Yeah, add a PCB. This is what we want to add and whether or not we're adding it with priority. If we're adding it with priority, just add it to the normal queue. Otherwise, we're going to add it to the queue that had a certain priority and we're going to just add it to the end of that line. Okay, queue is a line. That makes sense? Let's see. Then we had, where's our queue factory? Do we have a homework assignment for today?
No.
That was last time. You had to write some stuff, right? Oh, that was the one line. This guy right here. Or I guess a couple lines that you had to update something else. This dude right here. Yep, that was last class. Not for this class. All right, so, so bottom line is when we're working with these queues, we need to be able to have some sort of logic surrounding getting things in and getting things out of the queue. So moving it into its own data structure where we can organize queue-related stuff into one place is beneficial. Make sense? All right. So where do we stand right now? I think we kind of started drawing a picture last time, right? Yeah. We want to get to the point where we're ready to like pause our simulator and then move on to the next theory stuff and then come back and add stuff to our simulator and so on and so forth.
I found
14? Ah, nailed it. First try. Oh, did you see I went to my first Packers game?
I saw that. It
Yesterday?
looked awesome.
You're lucky they won.
They lost, man.
No, they won.
It was close.
I didn't care. Yeah, but it wasn't a good game. I mean, the very end was exciting, but like the Packers played well for the first quarter and a half, and then just kind of stopped playing football. And the other team was playing, like they were taking, like the other team wasn't playing the first quarter and a half, and then the Packers stopped playing the next quarter and a half, and then the last quarter was kind of back and forth a little bit, and then it was exciting at the very, very, very end.
From an entertainment point, the Colts game was more entertaining.
Who won?
The Colts were playing against New England, right? New England won.
Yeah, it was hilarious.
When they go out and check the inflation level of the footballs. That would have been pretty funny. They made like a big spectacle of measuring the PSI of the footballs.
Right in between plays.
Yeah.
One thing I did. This is like legitimately Christian worldview, I think. One thing was really cool after the Packers game is there was a big group of players that circled in the center of the field. This is 15 minutes after the game was over. I mean, this was not like right away. From both teams, probably 15 players, something like that, stayed on the field and did like a prayer thing, right in the middle of the field.
I saw that at a different game, but I don't know what it was for.
I think there's like a sub group of NFL players that do like a Bible study or something like that. Yeah, I mean, they didn't make like a big scene of it. They didn't have microphones out there or anything like that. I just thought it was kind of cool. Especially from players from two different teams that were just trying to kill themselves for the last 4 hours. So, yeah, the other thing I found was neat that I didn't really appreciate before was historically I've always kind of found it exciting when Packers lose because then you get to see like the human misery that surrounds the city and stuff. You know what I mean? Like people get depressed when the Packers lose around here. Well, I thought it was really cool that how nice the Packer fans are to the opposing fans at Lambeau. I mean, they're like, they were going up and giving them like hugs, but not like making fun of them. We beat you hugs, like legitimate, like, hey, good game, blah blah blah. I don't know. I thought it was kind of interesting. It wasn't the, but then again, I could have had the same lecture with the people sitting around us about the whole mixed company F-bomb stuff. Man, my wife texted our pastor and said that the lady next to me is scaring me. So, yeah, interesting experience.
Have you ever been to a professional hockey game?
I think when I was younger, I went to a Blackhawks game, but it was years and years and years ago. So I don't really remember it.
Company is much worse.
What?
In terms of cussing.
Really?
Almost.
I can't imagine. I mean, I can imagine it being equal. Literally every word that came out of this woman's mouth was prefixed and postfixed with the F word.
Yeah,
Every word.
that's pretty much like everybody around.
Yeah.
When you're at hockey.
I guess,
I'm gonna take a video.
I guess what's interesting is why people would take a sport so, like, why does it have that huge of an impact on their life? It's sad, really, isn't it?
Well, and it's not only here, because we went to Ireland many years ago. We went to a pub, the rugby games.
Oh, they kill people over those
and you
things.
had all the Irish folks sitting at the bar, cussing at the TV, watching the rugby game.
Well, I mean, yeah, isn't it like, soccer, there's deaths
Yeah.
at some of these soccer games. Like,
Soccer
people
really
get trampled and stuff.
Soccer
What's that
really
movie?
gets crazy.
Uh,
I'll take a video of you with
yeah, I mean, I think every soccer game is basically like Black Friday here.
Yeah.
It's basically like a Walmart parking lot on Black Friday. All right, so let's keep cooking here. So we have started our data structure for our CPU, I believe, but we left it blank. Okay, we built our Q factory, and then we started thinking about our CPU scheduler. Right. So right now we have this idea. We have our process scheduler minimally built. It does stuff, right? We have our Q factory. This guy does stuff. So now we have to create this relationship right here where our CPU scheduler is working in conjunction with our CPU on one side and our Q factory on the other side. Okay. Now, what does a CPU do? That's our Pac-Man guy, right? So he basically is fed a PCB, and then he operates off of that PCB by eating instructions. Okay? So we need to create the scenario where a PCB loads onto the CPU. That is, context switches on and context switches out of the CPU. So at any point in time, the CPU is going to be managing a PCB. One PCB, right? All right, so at the very least, our CPU is going to have a nice little pilot seat, if you will, for a PCB. So we're going to have a private PCB, the PCB. This is inside of our CPU. All right, so this is going to be the one dude that is, I guess, working within the CPU. All right, now we're going to have a couple of functions. One to context switch in, another one to context switch out. Now, we're going to go ahead and let's just create a constructor for our CPU that initializes the PCB to null at first. When a CPU first comes into existence, it's not eating right off the bat. Something has to be fed. That's from our CPU scheduler. Okay, so we'll create a public CPU, takes no parameters, and this guy will set the PCB equal to null. That would be the default behavior anyways, but I like to make it explicit with our constructors. I don't like relying on default stuff. And neither should you in any sort of languages you're working with. If you want something to happen, explicitly make it happen, not only to ensure it happens the way you think it happens, but also seeing this gives us what we believe the final state of instantiating a CPU should be.
Maybe that's why Hexton drops the F-bomb. He wants to be explicit.
I don't necessarily have a major issue with flowery language in the right company. But when you're in mixed company and you don't know what, you at least want to make some sort of moderate effort not to just offend folks around you. I mean, several of you know me outside of the classroom. I have a little bit different cadence to my speech outside of the classroom than I'm doing in the classroom. You gotta, I don't notice the difference. It's the same thing. And as we move farther and farther from campus, it drastically goes downhill.
Brandon thought my dodos on Arc are actually are named goats. I gave them goat names.
All right. Well, you'll have to give me a tutorial on training dodos at lunch today or something.
You can use a slingshot to do it. It's easiest.
To knock them unconscious.
Yeah, you need narco berries.
Oh, once I start beating them up, I can't stop.
Because they lay down.
Especially when they start screaming. I tear up, actually.
They fall down like they die.
I know, and then
I thought they were dead. And I'm like, wait, this thing isn't dead. It's unconscious.
Why does that happen with a person?
All right, shut up. Shut up. This could be lunch conversation. We can talk about that. Let's get through. Otherwise, I won't be able to give you a homework assignment. I have a huge project planned for you guys over fall break.
Oh, great. I'm going to be on Percocet. Are you sure you want
I won't give you homework over fall break. I'm not, well, I am that evil, but.
Who are you kidding?
All right. So, anyways, when a CPU is born, it has the capability of managing a PCB, but doesn't actually have one. Okay. So we need to have a way of getting a PCB onto the CPU and also getting a PCB off the CPU. So we call that context switching, right? Context switching, expensive but a necessary evil. All right. So this is our chance to emulate the idea of context switching. All right. So in our little simulator here, we're kind of creating all these little mechanical moves that has to happen as PCBs kind of work their way through the machine. It's kind of like How It's Made, if you've seen that show.
I love it.
Yeah. So do I. It's a great show.
It's a big thing.
So let's go ahead. We're going to create a public function called context switch. Let's say context switch in. Okay. or context switch on in, doesn't matter actually, probably. Public void context switch in, and this is going to be a PCB that is moving on to the CPU. All right, so this is that idea of unpacking our bags on the CPU. Make sense? Did I say something?
You've been saying contact this whole time, haven't you?
No, there's no way.
I have been having an argument about this.
No, it's
like,
context.
oh my gosh.
I thought it was contact until the
Textual.
So
get together. And
Is it bad pronunciation or did I speak too quickly?
I don't know. Because
Either one is valid. I mean, I'm just interested.
I'm
I think
not
they're just
sure.
very similar words.
We were just waiting for you to write it out because we didn't know which one it was.
Well, it's been written on one of the slides.
Yeah.
A future slide that we haven't hit
It
yet,
has
but
been written.
It has been written on previous slides too.
So now it's canon.
Yeah, sorry.
Christian worldview.
Christian worldview. All right. Yeah, it's a
Mixed company,
context.
Christian worldview.
What's up?
Mixed company, Christian worldview.
Exactly. Plus, every single time I say the word no, K-N-O-W, that's it's like I want a slot machine. All right. So, anyways, we have our context switch in. So this, we have to look at this in terms of what a PCB does, because this is that idea of we just arrived at our hotel room, now we need to unpack our bags, right? So out of curiosity, who was right? You think you were right? No, all right, so here's all the crap with a PCB. So when we think about this guy, when we have to context switch in, we are going to have to copy those register values over to the CPU. All right, and this is a collection of registers, and we do write register up here. Yeah, here's a register. A register has a name and a binary value. Okay, so for what we're going to do here, we're going to have to initialize our registers on our CPU as part of the constructor for our CPU. Okay, so we're going to come in here to our CPU and we're going to have a linked list of registers, private linked list of register called the registers. And this guy will be a new linked list of register. And then we're going to import java.util here. Okay, so a CPU is now going to have his collection of registers. When the CPU is born, we have to go ahead and give it those registers. Okay, now registers are going to have a name associated with them. All right, so whenever Intel ships a new processor, that processor is going to have some sort of superset, likely, of last year's processor in terms of the registers it has available. We're going to keep ours pretty simple. We're just going to have 4 registers, AX, BX, CX, DX. Okay, so we saw that a register, which is inside of our PCB, right, has a name and it has a binary value. Realistically speaking, we probably should move register over to our CPU. CPUs have registers, right? PCBs keep track of register information, but CPUs actually have registers. So we've just decided, rather than create our own separate class that holds the register class in it, since it's so small, we would just have it we would embed it in one of our other classes. So this is more of an organizational decision we have to make. So we're going to say, we're going to take the register class out of PCB and we're going to insert it into CPU. From Java's perspective, it doesn't matter. Java's it's a 2-pass compiler, so it's gone through all of the files and read in all the symbols in the package, so it knows about the register class before we start creating instances of registers any place. All right, so you notice that PCB is not broken now when we get to our linked list of registers here. It knows about register after we saved everything and it made its pass again. Okay, so this is more for us human organization perspective. And we are playing with fire a little bit here. We can certainly make an argument that register should just be its own .java file, so it would be easier to find if we ever needed to work directly with it. But if we just make the decision that we're going to keep our extra classes in the same files with the kind of the dudes they belong to, we can probably hunt and peck our way and find what we need.
So did you cut register or create a copy of it?
Cut it. Yeah, you only want to have it one place. Otherwise, we'd have two classes with the same name. So based on that, wasn't that a stupid question?
Yep, it was.
How many of you believe teachers when they say there's no such thing as stupid questions?
But not that stupid.
There's plenty of really?
I have heard too many stupid questions.
Go hang out with the Army.
And see, Austin is usually not stupid. So that was just a lack of critical thinking.
Well, plus I'm multitasking.
You doing homework in another class?
Studying for midterm.
You're studying for somebody else's midterm during my class while in the front row? What class? What class is this?
Business communications. It's a team thing, so I have to do it for my partner.
Who's your partner?
I don't know.
Just some kid?
Pretty much.
Well, there's no reason. You don't even know who your partner is?
Megan Stingle.
Oh, no, you just made up a name just because I.
Studying in class, making up names.
Who studies for another class's midterm in the front row? I mean, you relocate. So this is why you guys get such crappy grades in your quizzes. You're just missing huge swaths of information.
Yeah, but we're acing those midterms.
Are you? Are you going to ace this?
Hopefully.
I expect a 95 or better. Otherwise, you get a 0 in this quiz, whatever you got. Hey, look, no pressure, but pressure.
We're studying.
No, he's really not going to pay attention.
All right.
Back to it.
Stupid question because I'm studying for somebody else's test. This is what's wrong with education today.
Well, at least he was honest. You guys get points for honest.
Christian worldview.
Okay. See, well, I mean, if anybody should get points for honesty, it should be Levi all the time. I mean, who even knows what they're working on back there? Well, at least I sit in the back.
He has nothing in front of him.
No, half the time Levi's just out. He's just back there. His eyes are open, too. He's learned how to breathe through his eyelids like the Venezuelan thunder lizard things.
Now who's making sense?
I've gotten very good at not paying attention.
Yeah, I have a buddy who says that he's mastered the art of doing nothing. Hans.
Oh.
Hans says he's mastered the art of absolutely doing nothing. He could just sit there for hours on end. And just turn everything off. Doesn't even think. All right. So we've moved our register class into the CPU class file just because it makes...
Doesn't that need to be under some class?
Nope, doesn't matter. As long as classes aren't inside classes.
Threw an error on mine when I saved it.
Well, you did it wrong then.
Just remind me, what's the default for class if we don't declare it as public or private?
It's called project.
Okay.
Yep. Yeah, so in Java, the default, which I don't think you can write that. I don't think you can say, no, not project, sorry, package. Does it let you write that? I don't think it'll let you specify it. Yeah. Yeah, because the package keyword actually is up here at the top if you want to create a package, which we typically don't do.
Hit save.
Well, we typically don't do it for, based on what I've told you. I've seen several assignments turned in before that have package stuff on top. So just FYI, when you do that, I absolutely 100% know you copied it from some other resource, but I guess you win some and you lose some. But yeah, if you don't put anything in front, that means it's accessible anywhere inside of the package. And if you notice over here, Eclipse gives us a default package that everything just belongs to, which says anything that's in this folder belongs to the default package. Okay? Make sure that your class isn't inside of the other class somewhere.
No,
Curly
mine's
braces.
up top and saying the type register is already defined.
That's because you were making fun of him for asking the stupid question, but you didn't listen to what he said. If you go back to your PCB file, you need to actually delete register from
I
there.
didn't save PCB, that's why. There we go. Hey.
This is why Levi spaces out so he doesn't have to deal with that. All right. So, CPU knows about the register class, so now the CPU is going to have to, when we're Intel, we just shipped this new CPU, and here's the constructor for that new CPU. We're going to go ahead and fill this guy up with some registers. All right. So we probably want to go ahead and build into our register class a constructor. Otherwise, we'll have to create a register and then set each of those variables independently. So this is the first time we're actually using our register classes, our register class. So we're going to go ahead and create a public register. This guy will take in a name. All right, and right now we have a string representation for a register. We're going to say all of our registers start off as empty initially. But for us, empty is going to be a whole bunch of zeros. All right, we're going to say all these are 8-bit registers. Just for the sake of arguing, for no good reason otherwise, other than just say they're 8-bit registers. So we have a register that's going to take in a string name. We'll say this dot name is equal to name. And we'll say this dot binary value initially is going to be the starting value of that register, a bunch of zeros. All right. Rest assured, we're not actually going to be writing CPU magic trick logic in here, so we don't have to really worry about what's in there. We're just going to kind of fakesy say, yes, I'm executing instruction XYZ. Nailed it. increment program counter, just as our simulation goes. All right. So this guy is how we build a register now. So what we'll do here in the constructors, we'll build our 4 registers: AX, BX, CX, DX. There's a lot more registers than that on our modern CPUs, but that'll be good enough for us.
We built them all.
No. So we'll say this dot the registers, this dot the registers dot add. We're going to add a new register, and we're going to add to this guy a register called AX. And that'll get its default value.
Is there a reason it's called AX?
That's a good question. I'm guessing yes, but I don't know what it is.
In the real world. Is that what you're saying?
Yeah, I mean, AX, BX, CX, and DX are real names of registers from the original x86 processor. Maybe it's has something to do with the original processor being called x86. So they just said, well, we're going to have 4 registers, A, B, C, D, and then you put X after it, I guess. Because there is, in some of the magic tricks, you can access the first half or the second half of the registers. I think it's AL, AH, I think, A low, A high. So if it's an 8-bit register, you can access just the nibble, the first 4 bits, by saying AL. So maybe the X says, give me all of it. But, say this again. Is it AL, AH?
Is that fear of God?
Is it?
Allah?
Oh. Christian worldview. No, because I said no, that's not what it's for. Christian worldview. All right. So we went ahead, and as we're building our CPU, we'll initialize the initial PCB to nothing, and then we'll go ahead and say, here are your 4 registers. We've soldered them on. You pointing out the backpack? Is that what you're doing?
No, just didn't react at all.
Whose homework are you working on?
He's designing.
What is it? Reading up on virtual machines. Wasn't that like several assignments ago?
Yeah.
He's gonna make virtual.
I was reading up on it. Just on
He's making a virtual training camp.
He's applying the virtual clean room technology from the software engineering class last semester. All right, so we're just going to say that this new CPU just has these 4 registers. Fine. So now we have our context switch. When we context switch in, a PCB is going to go ahead and it needs to fill up that register with all of the, or fill up the registers on the CPU with the old values, right? So we need to go through and we need to find for each of our registers in our CPU, we need to grab that current value of that guy from each of the registers in our PCB. Make sense? Okay. So, for our register, we probably need to have a a getter for the name, as well as a getter for the value, and a setter for the value. So we need to be able to get the name of a register. We can say, is your name AX? Because I need to fill AX. We also need to get the value of that register. So I need to get the binary value. And we also need to set the binary value from when we're going in, right? So we'll go ahead and right click here. We'll go to source, generate getters and setters. And we'll go ahead and give us both for the binary value and just give us the get for the name. All right, so now our register class can do a little bit more. So as we're context switching in, we need to go through and we need to get the value of every single register from our PCB. Now, our PCB currently has a private field called the registers, or called register values. All right, so these are the register values that he has stored. So I need to be able to get those values, get the value for register from our PCB. So we need to build that ability into our PCB. So public string get value for register, string register name. All right, so we need to go through all of our registers, and if the register has the same name as register name, then we're going to return the value. Make sense? So for register R in this dot register values, so this will be a for loop that goes through each of our registers in register values. If R dot get name dot equals register name, if that's a true statement, then we'll return R dot get binary value. So the function will immediately end. All right, so we'll ask a PCB. It'll be the CPU during the context switch in thing. It'll say, give me the value for register AX. This guy will go through, find the value of register AX, and return that value. Make sense? Now, if we didn't find that guy in here, we're going to return null. Under what circumstance would we find return null? Okay, which would happen when in our CPU simulation dealie? Under what circumstances would a PCB not have a value for register AX? What? The first part of that didn't seem like English. Did you say when we exceed?
Yes.
Oh, that sounded. Ooh.
Oh, sorry. When we exceed our 8-digit register value.
Nope, think simpler than that.
When we get through, we don't have any more instructions to pass it.
I'm a brand new PCB. I was just born. I haven't been on the.
When is a new PCB?
I haven't gotten the CPU yet. I haven't stored any values of registers, right? I'm brand new. This is my first time in line for the CPU. First time riding the bull. Euphemism, Christian worldview. I don't have stored names of all those registers. I haven't been there before. I didn't store them when I left. Right? So that's when it would be null. When it's the first time that guy's on there. But we can't check for his status to be new because the status is actually ready if he's in that queue. Correct? All right, so we're going to have to look at the value that comes in from this. So this is us asking a PCB, give me the value for the register named this. And this guy's either going to return the binary value for this for the CPU to put into his equivalent PCB, or it's going to return a null. Okay? And if it returns a null, then we're not going to do anything. All right, so we're going to go into our CPU. So here's our context switch in. So this PCB is getting onto the CPU. So we're going to go ahead and we're going to loop through all of our registers. So for register R in this dot the registers, we're going to ask the PCB, we're going to say P dot get value for register R dot get name. So we're going to say give me the value for that guy. All right, and we're going to say string val is equal to that. Then we'll ask the question, if val is not equal to null, r dot set binary value to val. So inside of our CPU, we're going to spin through all the registers that the CPU has, ask the PCB for the current value that the PCB has for each of those registers, and copy them over where we have them. Make sense? Now we know after the very first time the PCB's been on the CPU that he's going to have the last state of all those registers. But the very first time we do need to check for that null value. All right, so we really probably want to consider this from a performance perspective, seeing as though our CPU needs to be really fast and our CPU scheduler needs to be really fast. We probably want to minimize the number of extra questions we're asking.
So is it being overwritten every time it goes into the CPU?
Has to be.
Okay.
Because if I'm the PCB coming onto the CPU, I need to give the registers the values that it left off at last time he was working with me.
Okay.
But we're relying on the previous PCB who's left the CPU to have copied the current values over before we overwrite them. Okay? So when we context switch in, we're going to go through, fill up all the registers for our CPU with the values the PCB had stored. Then we're going to go ahead and we're going to say this dot the PCB is equal to P. Let him know who the current PCB is. So now we have public PCB context switch out. What should this guy do? He should store all of the register values in the current PCB. Then set the current PCB to null. Then return the PCB that is leaving the CPU. So that's what context switch out should do. All right, so for your homework, write context switch out inside of the CPU class. So you'll have to write the code that goes through, copies the current value of all the registers into that current PCB, so it has them for next time, then actually takes the guy off the CPU, setting the CPU's PCB to null, then returns the PCB that just left the CPU. Make sense? Somebody's going to be calling this guy. They haven't called it yet, so we just need to write this ability first. All right, so what I'll do here is let's make sure we have our current version up on CDOSM source, and we'll say git add star.java. Git status. Those are the new files we've created since the last time we've done this. Then history grep for push 540. Just copy this real quick. Git commit -m. Added PCB. No, added CPU stuff. Do that. All right, so I'll put the assignment up on Blackboard with a link to the current GitHub, so you have it. And I will see everybody on Wednesday.
So
Right? Today's Monday?
I just wanted to remind you I won't be in class Wednesday.